Good day once again. It's Success. It's Ishala Adeji Michael, and welcome to Success Enlightenment. We will continue the Success Enlightenment. We will continue by illustrating some of the rules of differentiations. We'll be starting. We have copies of videos already on differentiation. We've discussed the rules of differentiations. We've gone further to illustrate how we differentiate through the first principle. We've gone further by solving certain examples on how to apply the rules of differentiation we've been taught, and we continue in that order by other solving some questions applying the rules of differentiation. Today, the first question I'll be solving to illustrate rules of differentiation will be, let's say we are given y equals to x raised to power 4 minus 3x squared plus 4x, everything raised to power 3, and we have to find the y ds, that is the derivative of the function of y, or we have to differentiate with respect to s. That they are still asking us the same thing. And if you look at this function we given, you look at it clearly, this function, it's clearly a function of a function coefficient. So we are applying the function of a function to solve it. And the first thing you have to first ascertain when you are given any question, as far as differential calculus is concerned, is you have to look at the laws the question is required of you to solve it. So you don't just go on and no, you have to first be able to ascertain that. If you can't ascertain it, that means one thing, you've not been able to master that law well, and kindly just leave that questions and go and solve another question. It means if you attempt it, you won't get a meaningful mark there. So it's as simple as that. So we are looking at this, we are looking at a function of a function, because we are having y, which is having something in bracket or raised to power 3. So when I solve it further, you will get to discover why it is a function of a function. The first thing I will do here is I will write this function in the standard form. Y equals to f of s, such as s raised to power 4 minus 3s raised to power 3 plus 4x, everything raised to power 3. And I'm asked to find the y, the s. That is, I'm asked to find this equals to this, or the y, the x. This is what I'm asked to find. Now, for me to do this, first thing, let's u equals to s raised to power 4 minus 3s raised to power 3 plus 4x. Let this be our u. And if this be our u, then what will now be y? If this is u, what we got, then our y will now be equals to what? U raised to power 3. Now, from here, definitely it is clear we are dealing with a word chain rule. It says that y is a function of u, whereby u is a function of s. That is, we can derivate our y with respect to u, and we can find the derivative of u with respect to x. So what we do here is simply we recall from chain rule. The y, the x here equals to what? The y du times du dx. So what you do simply is what? You find the y du. Our dy du equals to what? Derivative of what? U raised to power 3 with respect to u. We set it as what? 3u squared. When you apply your power function rule, 3u squared. And at the same time, our du, the s, will be what? Derivative of s raised to power 4 minus 3s raised to power 3 plus 4x with respect to x. And this will give us what? 4s raised to power 3 minus 9s squared plus 4. So bringing the chain roots down again, dy dx equals to what? Dy du times du dx equals to 3u squared times 4s raised to power 3 minus 9s squared plus 4. Now recall, your u is what? X raised to the power minus 3x to the power 3. Recall, your u equals to x raised to the power 4 minus 3x raised to the power 3 plus 4x. So you substitute this for u here. You substitute this for u. When you substitute this for u here, what we have is what? Your dy dx equals to what? 3 into x raised to the power 4 minus 3x raised to the power 3 plus 4x, everything multiplied by 4. Remember, your u have a square, 3u square. So you put a square there into 4x raised to the power 3 minus 9x square plus 4. And this will be the what? Our dy dx. This is simply a what? A function of a function question. So the step is very, very simple. The step is very, very simple. Once you remember the chains rule, it's around a function of a function rules, and you're able to clearly ascertain that this is a chain rules question. So just go on with the procedure. Recall what chain rules tells you. Don't forget, you got this in your own example, or maybe in exam situation, your own, when you are solving, you might not use u. You might not use u. You could use p. You could use q. It doesn't matter. Only that if you use q, what you have here is what? Dy dq times dq dx. So that's what you'll be having there. And by this, we come to the conclusion of this question. Let's look at further examples. The question we're given here is this. We are asked to find the y dx given y equals to 3 divided by 2x squared minus s plus 4 raised to the power 3. Now, when we have something of this nature, very many times we are dealing with what? Quotient rule. But this is not a quotient rule question, in the sense that what we're having as our numerator here it's not a function of x, it's a constant. We're having there, it's a constant. So what we simply do to solve this question is, number one, since what we're having here is a constant, definitely it is not a quotient rule. Don't apply quotient rule with this question. If you do, definitely you will get the same answer, but of certainty, the method you have used, the procedure you have used is wrong, so you are going to lose mark. In as much as what you are having at your numerator and denominator, if any one of them is not expressed as a function of x, then it's not a quotient rule. So what you do, you apply a simple knowledge of what? Indices, and write the given function. What am I saying? Solution. So y equals to what? F of x, standard form of the function. This same thing as well, you have what? 3 times 1 over 2s squared minus s plus 4 raised to the power 3. Do we agree? Yes. If we agree to that, also if we apply our knowledge of indices, remember our knowledge of indices to this, you can see our y equals to what? F of s equals to what? 3 into 2s squared minus s plus 4 raised to the power minus 3. I hope this is very well understood how this turns out to be this. Because in indices, if you have what? X raised to the power minus 3, this same thing as what? 1 over x raised to the power 3. So that's exactly what we do here. That's exactly what we have done here. No magic. We just apply this, our basic understanding in indices. The only thing we do is we apply our basic understanding in indices. So going further from here, this has clearly made us understand that this is also a function of a function question. This is another chain rule question. So therefore, to solve, we said let p equals to 2s squared minus s plus 4. Now if p is 2s squared minus s plus 4, then our ui will now be equals to what? 3p raised to the power minus 3. Okay? 3p raised to the power minus 3. So by this we can apply chain rule. Apply chain rule. That is, dy dx equals to dy dp times dp dx. So what's our dy dp here? Our dy dp here is so dy dp derivative of this with respect to p, this will be what? Minus 9p raised to power minus 4, minus 9p raised to power minus 4. That's our dy dp. Then what is our what? dp dx. This p with respect to s, this equals to what? 4x minus 1. So our dp dx is 4x minus 1. So therefore our dy dx will then be what? Minus 9p raised to power minus 4. Recall, it's equal to dy dp times dp dx into bracket 4x minus 1. That is a multiplication. What's our p? So we substitute the value of our p here. So we have dy dx equals to minus 9 into bracket what? 2x squared minus s plus 4 all raised by what? Minus 4 multiplied by 4x minus 1. Now the same law of indices we apply here, we are going to what? Reverse it here, in the sense that this will now be equals to, we have minus 9 into 4x minus 1 all over 2s squared minus s plus 4. 2s squared minus x plus 4. Now this can still be solved further. You can multiply everything here by minus 1, or you can actually multiply everything here by minus 9. So if I choose to multiply everything here by minus 9, what will I have there? I will have this will be minus 36x plus 9 all over 2s squared minus s plus 4. And this can be written as what? As 9 minus 36x 2s squared minus s plus 4. This 9, this 9, this not 8, this 9. And these are what? dy ds. These are dy ds. And that is the answer to the second question. Still the same procedure as the first question. We identify it's a chain rule. We use our knowledge of indices and the application of what? Chain rule. And that's why a mastery of ECN 103 is the necessary foundation for success in ECN 104. Okay? But if your students will discipline enough and you take notice of every little change you see in every calculation, then even if it's a 103, you might have joked with it, you'll still be able to catch up and have excellent grade in ECN 104. Alright, now let's still take furthermore examples. Now we are on the third illustrations. Okay, the third illustration we'll be checking out. This is we're given y equals to ln 5s squared plus 4s plus 12. We have to find the derivative, that is the dy dx. Now, if you look at this question again, the first thing we have to do is identify which law of calculus or which law of differential calculus this question is required of us. Now, if you look at it, we see that our y is a function of ln. That definitely tells us that we are applying this is a logarithmic function. But still, if you look at this clearly, we see that it's also a function of a function. So simple, we start from the function of a function. So from here, we write it as y equals to f of x equals to ln 5s squared plus 4s plus 12. Okay. From here, what do we do further? We say let u equals to 5s squared plus 4s plus 12. Then therefore, we can write our y equals to f of x equals to ln u. Okay, so from here we already put it in what? In chains rule. So what does chain rule says? Applying chains rule, that is the y ds equals to the y du times the u ds. Now from here, what be our dy du? Our dy du will be what? Derivative of what? Derivative of ln u with respect to u. Now this we apply our knowledge of what? Logarithmic function rule, which we say the logarithm of u, the derivative of ln u du, it equals what? 1 over u, equals to 1 over u. So also here we find our du ds by applying the power function rule, and this will be derivative of what? 5s square plus 4s plus 12 with respect to s, and this will be what? 10x plus 4. So then our dy, the x here will be what? 1 over u times 10x plus 4, which is same thing as what? 10s plus 4 all over u. Now recall, what's our u? Our u is 5s square plus 4s plus 12. So substitute that here, so that our dy ds equals to what? 10s plus 4 all divided by 5s square plus 4x plus 12. Now if we look at it, we cannot solve any further. We cannot factorize anything here. So therefore, this remain our final answer. So our dy ds will be 10x plus 4 all into what? 5s squared plus 4s plus 12. Alright, I can further, maybe I can put it this way: 2 into 5x plus 2 all into what? 5s squared plus 4s plus 12. We are still saying the same thing. Alright, let's go further and still solve this question. Here we are given 5s squared plus 8y squared equals to 25. We have to find the y, the heads. Now, the first thing I said earlier was that we're given any question, the first thing you have to ascertain is what? Which law of differentiation is the question requiring you to apply? Now, from here, if you look at this clearly, you see that this function is not explicitly stated. So therefore, it is an implicit function, for you cannot express this as a function of x, neither can you express this as a function of y. As x can be the dependent variable, also y can also be dependent variable, depending on our interest, what we are bothered about. So therefore, this is an implicit function, and we are going to differentiate this implicitly. So what do we do first? The first thing is we write this in such a form such that we have 5s squared plus 8y squared minus 25 equals to 0. So therefore, we differentiate implicitly. Now what it means to differentiate implicitly is what? Each term of the function, you are going to differentiate it with respect to s and with respect to y respectively. That's what it means to differentiate implicitly. So what that implies mathematically, well, this is what you are saying. You take the first term here. You take it, then you have what? You have you have dy dx of what? 5s squared plus dx of what? 5s squared. Alright, plus the second term, dy dx of what? 8y squared plus what? dx of what? 8y squared. And the last term here is the constant, so the derivative of a constant will always be 0, either with respect to s or with respect to y. So we can always put minus 0 and everything is equals to 0. So now let's work this out. Derivative dy dx of this, derivative of this with respect to s, this will give us what? From here, there is no what? There is no y. If you look at this, we don't have y in this function. What we have here is what? Is x. I want to derivate this with respect to what? Y. So therefore, all we are going to do here is everything here will be equals to what? Is 0 plus. Now we get here, we have what? This is x with respect to s, so we have what? We have 10x dx dx. This one will be 0 dy dx. So now start from here. Derivative of this with respect to y. So we have what? 0 dy dx. Since none of these terms here has y, we have 5x squared. There's no y here. So that's why we have here 0. We treat this as a constant. So plus here, there is s and here is, so we can find the derivative, which is what? 10x dx dx. So when we get here, yes, here we are having y and we are having y, so we can find the derivative. Here this will be what? 16y dy dx plus, now this x and there's no x there, so therefore we treat that also as a constant, plus 0 minus 0 equals to 0. So when we write this out, this will be 0, this will be what? 10x. Ds same thing as what? 1. This will be 10x. This will be what? Plus 16y dy dx. This is 0, this is 0 equals to what? 0. So all we have to do here is we make dy dx subject of the formula, since we have to find our dy dx, which is our derivative. So here 16y dy dx equals to minus 10x. So therefore, our dy dx, that will be divided both sides by 16y, equals to minus 10x divided by what? 16y. And this is equivalent to this divided by 2, this will be minus 5x all over 8y. And that's the what? That is the derivative of the function we are given. It is an implicit function. So what we're doing simply with an implicit function is what? We are differentiating implicitly. That is, each term separately with respect to s and with respect to y. So that's what implicit function is talking about. Let's further look at least one more illustrations. So from there we can continue in another video. Okay, so let's look at least one more illustration. I'm going to look at this example. We're going to solve this question, and we end this video here. We continue with further illustrations in another video. Okay, so when we look at this again, we look at this very clearly. You cannot say with this, you cannot say s is the dependent variable and y is the dependent variable. Both of them can either be dependent or independent variable. So this makes this function also an implicit function. So therefore we are going to differentiate this implicitly. So let's differentiate this implicitly. Each time, the first time we have what? We are going to find the dy dx of what? S raised to power 3. And we are going to add this to the what? Dx ds of what? S raised to power 3. And we are going to add it to what? We're finding the what? Dy ds of 3 sy plus dx ds of what? 3sy. I believe you are getting it. We are going to add it to what? Dy dx of what? 9y square. 9y square. We add it to what? Dx ds of what? 9y square. Everything equals to what? 0. So let's start from here. Derivative of the y dx of this of x plus 3, since there is no y here, we treat this as a constant, and the derivative of the constant is 0. So what we have here is what? We have 0 plus this is s, so we can find the derivative of this. This will be what? 3s square dx dx. This is 0, this will be 0 dy dx. Okay. Here we find this, there's y here, so we can find the derivative. So what we have here is what? It will be 3x dy dx plus here there's s here, so we can find the derivative plus 3y dx dx. Okay. So here there's y, we can find the derivative. We have what? 18y dy dx plus here there's no s there, so it is as a constant. The derivative will be what? 0. Everything equals to 0. So this is 0, so everything here will be 0. This will be 0 plus ds same thing as 1. 0 plus 3s square plus this 3x dy dx plus 3y ds same thing as 1 plus 3y. This plus 18y dy dx equals to 0. So from here we collect the like times. We collect the like times here. So we have what? 3s square plus 3y plus 3x dy dx plus 18y dy dx equals to 0. So from here we solve with respect to dy dx. That is, we have 3x dy dx plus 18y dy dx equals to minus 3s square minus 3y. So from here we can make dy dx, we can factorize dy dx that we have what? Dy dx into bracket 3x plus 18y equals to minus into bracket 3s square plus 3y. So divide both sides by 3s plus 18y, then our dy dx will then be equals to what? Minus 3s square plus 3y, all in bracket, all divided by what? 3x plus 18y. Obviously, we can factorize 3 out in everything here. So we can have this equals to minus 3 into s square plus y all over 3 into s plus 6y. So therefore, we have 3 cancel 3, we have minus into s square plus y all divided by what? S plus 6y. And this will be the what? The final answer when we simplified the derivative of s raised to the power 3 plus 3sy plus 9y squared equals to 0. Now when you go through all these questions, just know that whenever you are solving, the first thing you have to identify is what principle of what? Of differentiation as the question required of you to apply. When you have that ascertained already, solving the question becomes very, very easy. And when you are solving, you have to be very, very careful. Don't rush too much and take your time. Be mindful of the signs. Minus and plus is different. And don't forget to use brackets intelligently. That could save you of so many errors. In subsequent videos, we still further illustrate the application or the usage of some of these laws of differentiation while solving questions in real examination situation. Alright, I will end it here, this video. Thank you once again. I remain myself, Ishola Adejumaike, and this is Success Enlightenment. Don't just watch, please like, subscribe, and comment. And feel free to call me directly on my number right here. Call me directly and WhatsApp me. Feel free to share me the questions you are finding difficult to solve. I'll be more than happy to solve them and share them with the world. Thank you once again. You are welcome. Bye bye.